This is the molecule 3,3-diethyl-1-pentene, and throughout this video, we're going to do 3 example problems showing how we can put a hydroxyl group at 3 distinct positions throughout this molecule, starting with the green position. For this case, we're going to focus on acid-catalyzed hydration, one of the processes of turning the alkene into an alcohol. Throughout this reaction, we form a carbocation intermediate. In this case, we'll have a carbocation rearrangement. We've seen hydride shifts before, and we've even seen methyl shifts. In this case, it's going to be an ethyl shift. Doesn't happen as frequently, but can happen. With that rearrangement, we go from a secondary to a tertiary carbocation in which the nucleophile, water in this case, attacks, leaving us with the hydroxyl group on that green carbon. But what about the red one? In this case, we want to favor a Markovnikov outcome like what we saw in the last reaction. But in this case, we want to avoid rearrangement. Oxymercuration demercuration is a reaction that avoids the carbocation altogether by forming another key cyclic intermediate that cannot undergo rearrangement. This results in the nucleophile still attacking the more substituted carbon with no rearrangements, leaving us with our hydroxyl group on that key position that we looked at previously. After the following demercuration step, we're left seeing that we have now a hydroxyl group on that red carbon. And for our last outcome, how do we put a hydroxyl group on that blue carbon? In this case, we'll favor an anti-Markovnikov outcome, putting a hydroxyl group on the least substituted carbon of the double bond. Hydroboration oxidation works lovely for this because the reaction works through a key transition state that favors the BH2 group to be on the least substituted carbon. And throughout the following of this reaction, there's a rearrangement that occurs internally within the molecule, swapping that carbon-boron bond to a carbon-oxygen bond, which downstream of the reaction leaves us for having a hydroxyl group on the blue position or the least substituted position. As the reaction concludes, we can see that we're left with a hydroxyl group on that blue position. I hope this video worked as a review and helps you in your continued studies.